You had 23. Don't apologize. Score on this one while we're here. So yeah, you find a function and its derivative right there. It's okay that it's different by a multiple, but 4t cubed, what's the derivative of 4t cubed? Well, 12t squared. The t squared is right there. So you do, this is that setup that we like to do right there. That's the setup we like to do. And then you substitute, integrate, and then substitute again. Remember, substitute, integrate, and then substitute back in. So here's the substitution, here's the integration, and then you substitute back in to get the final answer in terms of the variable you started with. The thing you have to take care of is the 12. Is there a 12 in front of the integral? No, there's no 12, so you have to get rid of it, so you put it over a 12. That's where that 12 comes from. Yes? Between a definite integral and an indefinite integral, what's the difference? What are these? These are definite. Why? They have limits of integration. They have limits of integration. Those are the two numbers that the fact that there are numbers there make it a definite integral. So we're going to learn how to do definite integrals with u-substitution. So these are actually two things we've done before. We know how to take apart integrals with w-substitution, and we know how to plug numbers in. So there's nothing truly new here. If we were to do this one with w-substitution, Mikey, what do you think w should be on this first one? What do you think w should be on this first one? Yeah, why did you pick x squared? It is the exponent. So the exponent is a natural choice, but what is nice about the exponent in this case? What else do you see in the equation? You see the what of x squared. What do you see? You see the derivative of x squared. Right. So in this case, you have dw is equal to 2x dx. So dx is equal to what? dw over what? Over 2x. Right. So now we do the substitution, and we do the integral of x e to the w, and instead of dx we write dw over 2x. And what's the nice thing that cancels on this one? The x's. If the x's didn't cancel, we'd be stuck, right? So the x's are gone. So we end up with, what, 1/2 of the integral of e to the w dw. Is that nice? That's very nice. Okay, so if we continue with this, we're at the integration stage. We've substituted, now we integrate. What's the integral of e to the w? E to the w, so we have plus what? C. And we're integrating this. Oh, we haven't substituted yet. Now we substitute. What does w equal? So it's 1/2 x squared plus c integrated from 0 to what? 2. Now we're integrating it. Yes? What's the question? I wrote that terribly. I just forgot the e. You're absolutely right, Liv. Sorry. It's e to the what? X squared plus c from 0 to 2. Now, when we're doing definite integrals, does that c matter at all? No. Because you subtract it off. It ends up always being c minus c. So what are we really doing here? We're doing, just to make it life easier for you, 1/2 e to the x squared from 0 to 2. Is that correct? Yes. So what do we have here? We have 1/2 e to the 2 squared plus 1/2 e to the 0 squared. What's 2 squared? 4. So you have 1/2 e to the 4th plus 1/2 e to the what power? 0. What is e to the 0? So what do we have here? 1/2 e to the 4th plus what? 1/2. No, I feel awake this morning? Like, I feel awake this morning. But it's good that you're catching these. Yes, it is always minus. So what is it? It's this minus 1/2, yes. That would be a totally fine way to write that. There's one thing some people might do, or some answer keys might do, to make that, it's arguable, prettier or not. What do you think the one thing they would do to the answer is? Well, they make it improper, or they factor out what? You might see this instead. You might see e to the 4th minus what? 1. That's actually really common. You might see this instead. Either one I would take for full credit. You'll notice one thing. Take a look at the work we did there. Take a look at the whole trail of work there. I dropped something as we work. In the middle, there's some numbers that are missing, actually. There are some numbers that are missing. Anybody see what's missing? What type of integral are we working at the beginning? What type of it is it? It's called a definite because it has the limits of integration. What did I stop writing in there? This is really, really, really important. These are what type of values? Are they x values or w values? Those are x values, right? So once we get into w land, we're now using w's, right? We're now using w. So is this correct? Is it 0 to 2 right there? It is not. It is not. So you have two choices here. You either can go all the way to the end, get to here, and then do 0 to 2, or do something a little different. What we could do at this point is, how many variables do you see right here? What letters? What's the only letter you see there? W. So if we're going to do W, we need it in W. What's the relationship between X and W? W equals what? So W in terms of X is X squared, right? So what's W evaluated at 0? So that goes there. But what's W evaluated at 2? 4. So this is why this is super helpful. You see this right here? You see that? Oh, actually, I'll put it right here instead. Right here. So instead of, we do 0 to 4 once we have just W, we do 0 to 4. So if I just gave you this on a test over here, 1/2 the integral from 0 to 4 of e to the w dw, what is the integral of e to the w? E to the w from 0 to 4. What's that going to be? 1/2 e to the 4th minus 1/2 e to the 0. Is that the exact same thing we got before? Yeah, it is. It's the exact same thing, but what did we get to skip? We got to skip all of this. The key thing to remember is this. Originally, these are x values, but once you get everything in terms of w, you can put it into w, and then you don't have to substitute again. Can this be super helpful? It can save you a little bit of time. It can save you a substitution. Usually when you do indefinite integrals, what do? You substitute, you integrate, and then you substitute again. This way, what can you do? Substitute, integrate, and then basically do a little tiny bit of substitution, like w equals x squared. A very common mistake is instead of doing 0 to 4, you did 0 to what? 2. If you did 0 to 2 and just integrated, is it correct? No, it's not. So let's do it that way on this one right here. What do we think w should be on this one? And I'm going to leave it right there. What do you think w should be here, everybody? Yeah, Annie, that's a great guess. 5 minus x. So what does dw dx equal, Annie? Nope. What? -1. So dw over, so close, close. dw is equal to negative dx. So what does dx equal? Negative what? dw. You have to keep track of those negatives. You drop that negative, this whole thing is wrong. So we have the integral. You notice how I do not write the limits of integration here? Of 3 over what? W times what? Negative dw. What can I factor to the front now? So we have negative 3, actually. I'll pull the 3 out too, right? 1 over w dw. Are you with me so far? How am I doing? Am I okay so far? So that's w to what power? So it's -3 to the -1 dw, right? We're in w now. What does w equal, everybody? What does w equal? So what is w evaluated at 1? 5 minus 1 is what? 4. So what's the lower limit of integration? So this number goes right there. What is that going to be? It's going to be 4. And then you do w evaluated at what? 3. So that's 5 minus what? 5 minus what? 3 is 2. So that number goes right there. So what do we now have? We have -3 integral 4 to 2. Is it okay that it goes from a bigger number to a smaller number? Yeah, sure. That's totally fine. You don't care. You can integrate backwards. That's fine. What is the integral of w to the -1? Someone could tell me. What is it? Exactly. There you go. So you have -3 ln of the absolute value of w from what to what? 4 to 2. So you have -3 times ln of 2 minus ln of what? 4? Do you remember? You could stop there. I would be totally okay with you stopping right there. You need to remember maybe a little bit of your log rules. I know it's Monday morning and you're seniors, most of you, so you might not be inclined to think that you really want to remember this, but do you remember what you do when you subtract logarithms? No. If you add its multiplication, if you subtract its division, so this is actually -3 times the ln of 2 over 4, which is -3 times ln of what? 1/2. Let's have fun with this. So keep in mind, everybody, this is a fine answer. I'm just going to show you all the different ways you could write the answer. 1/2 is 2 to the what power? Anybody know? 2 to the -1. So this is negative ln of 2 to the -1. What can you do with powers? You can bring it to the front. You can bring this to the front, so it turns into -1 times -3 times ln of, so what is that? 3ln2. Pretty cool, huh? This is great. Would it be awesome if you could remember your log rules? Sure. Logs are not difficult, but is it really easy to make small mistakes? Yeah, it is. Yeah, it is. So let's keep going here. Oh my gosh, it looks so terrible. So it goes 2 cosine of x times what? The derivative of what? Of cosine, the derivative of the inside. What is the derivative of the inside? So it's going to be -2 cosine x sine x. So if you choose to do that, that is what the derivative of cosine squared is. If that's what you choose to do, that is with the chain rule. You must be automatic about that or you will not pass the next test. I can't be clearer than that. So I loved what I saw there. You played around. What are some of the ones that didn't work? W is equal to, I saw cosine x, right? I saw W is equal to cosine squared x. Doesn't work, right? So instead, you ended up with W is equal to tangent x. That means that dw dx is equal to 1 over cosine squared x. So that means that dw cosine squared x is equal to dx. And hey, look, you can now substitute directly. You get w what? Cubed over cosine squared x times what? Cosine squared x dx, or dw, sorry. What cancels? The cosine. So at this point you have this right here, right? Let's turn it into w. What does w equal? Tangent x. So what's w of 0? That's tangent of 0. What is tangent of 0? 0. So that's still 0. But what's w of pi over 4? We just did it, right? Basically, are you going to do it now or at the end? And that equals what? No, tangent of 1/4 is 1, right? Hey, look, now we don't have to substitute again. So now what do we have? W to the 4th over 4 from what to what? 0 to? So that's going to be 1 to the 4th over 4 minus 0 to the 4th over 4, which is 1/4. Once you find the proper W, it should go pretty nicely. You're looking for that cancellation. You're looking for that simplification. That's what you're looking for. Okay, so let's pick, we don't have all the time in the world, of these 4, which one do you want to do? So let's pick a W. Let's do this together. What do you think W should be? Who has a bid for sine of 6 theta? Can someone tell me what dw d theta is then? Come on. 6 cosine of 6 theta. Yes, absolutely. So dw is equal to 6 cosine 6 theta d theta. So what does d theta equal? dw over 6 cosine 6 theta. We now substitute, and what do we end up with? Instead of sine, we have what? What do we make it? W to the 6th cosine of 6 theta times what? dw over 6 cosine 6 theta. What cancels? The cosine 6 theta is what can I factor out to the front? 1/6 actually, because it's in the bottom. So you have this, right? What haven't we written in? We haven't written in the limits of integration. We're going to change it to w. What does w equal? Sine 6 theta. So you can't simplify it, but what's w of 3 going to be? Sine of what? Sine of 18. Now, is that something you can simplify? Say no. What is w of 6? Sine of what? So again, can you simplify that? Are those trig values you should know? No. But where can you plug them in now? No, not yet. We're going to write these in accurate form. Perfect form. Sine 36 and sine of what? 18. What's the integral of w to the 6th, Liam? What's the integral of w to the 6th? What's the integral of w to the 6th? Exactly. Nice. And what are we evaluating that from? What's the first thing? Sine of 18 all the way to sine of what? 36. Now, could we write this out? Sure. We could factor that out. 1 over what? 42. So it's going to be sine to the 7th of 36 minus sine to the 7th of what? Of what? 18. That would be the exact answer. What would you absolutely need in order to get an answer? Calculator. But if I ask you for the exact answer, that's it. Nothing changed about the work we just did. Nothing changed. So how about you guys do, which one do you guys want to do on your own? A, B, or C? A? In this case, are you okay with where I am right now? You're okay with that? So you have to be able to evaluate that. So what's that going to be? It's going to be 25 over 2 plus 10 plus ln of 5 minus what? Because we're subtracting, right, Annie? Yeah. We're not adding? So what do we end up with now? 9 over 2. Yeah, 9 over 2 plus 6 plus ln of 3. And you can clean this up a little bit, right? You could clean it up. So what do you end up with here? You get 25 over 2 minus 9 over 2. So how many halves is that going to be? You're subtracting 9 over 2, so is that 16 over 2? And then you have, what, 10 and 6 is what? 10 minus 6 is... It's 10 minus 6 is what, 4? So we took care of that, and this. Plus ln 5 plus ln 3. Well, what's 16 over 2? So what is that going to be? 12 plus ln 5 plus ln 3. I would love you to stop right there. That would be awesome. But what can you do if logs are added together? Remember? Yeah, so you're going to have 12 plus ln of 15. That's also it. Okay, so these last two, let's just write down what we think the W should be. What do you think the W substitution on this one should be?